The combine harvester. The combine harvester is the machine that feeds the modern world, and it does the work of three separate tools simultaneously without stopping. It reaps, threshes, and winnows in a single, continuous pass across a field. The largest Class 10 machines weigh 25,000 kilograms, carry a header 18 meters wide, and produce 790 horsepower from a turbocharged diesel engine. That header shaves a path wide enough to cover 4 traffic lanes in a single sweep. One machine produces 100 bushels of wheat in under 30 seconds. The grain tank holds 20,000 liters and unloads at 150 liters per second, filling a cart faster than most people can walk the length of one. Onboard sensors track yield variations per square meter in real time, making every pass a data collection event as much as a harvest. Rubber track systems distribute 25,000 kilograms across a footprint, wide enough that ground pressure stays low enough to protect the soil for the following season. Without this machine, grain production cannot scale to feed modern cities, and bread and cereal shift from daily staples to high-cost commodities. The cranberry harvester. The cranberry harvester is the only agricultural machine that operates inside a temporary lake. Its operators create the night before work begins. Growers flood their bogs with 18 inches of water, then drive a machine fitted with large rotating paddles through the submerged plants. Each cranberry contains 4 internal air chambers, and once dislodged, the berries float to the surface. Workers drag 50 to 100-foot booms across the water to corral the floating mass before it is pumped onto a conveyor and into trucks. Between 90 and 95% of the North American annual crop is gathered this way. A dry harvest, used only for the fresh produce market, uses a comb device that lifts individual berries into burlap bags and grades them using a bounce test. Soft or bruised berries cannot clear a low barrier and are rejected on physics alone. Cranberries are perennial plants that can produce for over 20 years, so the machines must be gentle enough to leave the root system undamaged. If the harvester were too aggressive, the grower would wait 3 years for the next viable crop. Wet harvesting is the reason cranberry juice and dried snacks exist as affordable year-round products rather than seasonal specialties confined to one region of the northeastern United States. The sugarcane harvester. The sugarcane harvester is the industrial machine of the tropics, built to process one of the densest and most physically punishing crops on Earth for 15 to 18 continuous hours per day. It operates in 3 cutting stages without pausing between them. A topper removes the leafy crown first. 2 crop dividers guide the stalk toward a base cutter that severs it at soil level. The stalk then passes through contra-rotating rollers into a chopper drum that converts it into billets 20 to 30 centimeters long. High-velocity air extractors blow out leaves and soil before the billets drop into a trailing truck. A single high-performance machine processes 132 tons per hour and fills a 20-ton trailer in minutes. Running the chopper drum above 300 RPM actually reduces efficiency by shattering the stalks, so speed is deliberately held below that threshold, regardless of demand. Once cane is cut, sugar content degrades immediately, so the harvester runs in a continuous logistical loop with the mill, operating through the night under LED lighting to keep pace. Brazil and India together produce the majority of the world's supply, and neither country's output is achievable without mechanical harvest running around the clock. The stripper header. The stripper header is the most efficient grain attachment ever fitted to a combine, and it achieves that efficiency by ignoring the plant entirely. A high-speed rotor fitted with rows of stainless steel fingers moves through a standing crop and plucks the grain heads from the stalks, while leaving the rest anchored in the ground. The machine takes in roughly 80% grain and 20% residue, compared to a conventional header that ingests the entire plant. Because the combine's internal threshing system processes only grain heads rather than full stalks, the machine travels at up to twice the speed of a standard setup, and seed loss rates fall to 3.5% against 6.5% for conventional headers. The field after a stripper pass looks nearly untouched. Standing straw between 30 and 60 centimeters tall covers the entire surface, dense enough to catch snow and hold soil moisture through winter. In dryland farming regions across the high plains of the United States and the Australian interior, where precipitation storage determines whether the following season is viable, the stubble left behind is not a byproduct of the harvest. It is a water management tool that makes the next crop possible. The cotton picker. The cotton picker is one of the most consequential harvesting machines ever built, and a single modern unit costs between $600,000 and $1 million. Its mechanism is selective entanglement. Vertical drums fitted with hundreds of rotating barb spindles pass through open cotton bolls as the machine moves over the plant. The lint wraps around the spindles while the rest of the plant remains standing. A counter-rotating doffer strips the fiber off, and a fan blows it into an onboard basket. The John Deere CP 690 runs on 567 horsepower and compresses harvested cotton into modules, weighing 21,000 pounds directly on the machine while it continues moving through the field. One machine replaces the daily output of 120 manual laborers. Picking efficiency in ideal conditions reaches 99%. A separate variant, the stripper picker used in Texas and other short-season regions, removes everything, including unopened bolls, and uses internal separation to drop heavier plant material before the lint reaches the collector. The cotton picker eliminated a labor bottleneck that had defined the economics of the American South for 2 centuries, and its arrival in the 1940s directly accelerated one of the largest internal migrations in United States history. The potato harvester. The potato harvester moves more raw earth per unit of food recovered than any other crop machine in commercial use. For every 1 ton of potatoes it extracts, the machine lifts and processes between 10 and 20 tons of soil. A wide, flat plowshare cuts into the ground 7 to 10 centimeters below the surface, undercutting the entire root zone. The soil and crop mixture is lifted onto a series of vibrating sieve chains, where soil and small stones fall through the grates while potatoes remain on top. One machine clears an acre in 15 minutes. A manual laborer takes a full week. Soil moisture is the critical variable. Above 25%, the ground becomes a slurry that clogs the chains. Below 10%, abrasive dry soil strips the skin from the tubers and drops their market value before they leave the field. Any bruise on a potato can convert to rot during storage, so damage during harvest directly determines how much of a stored crop survives the winter. Farmers cut the green plant leaves several weeks before harvest using halm toppers, which toughens the skin and allows the mechanical process to run more aggressively without damaging the crop. Without this machine, the cost of labor would make potatoes, the primary calorie source for a significant portion of the global population, economically out of reach for the people who depend on them most. The forage harvester. The forage harvester is the highest throughput machine in agriculture, and its output is measured not in individual items but in raw tonnage per hour. The Claas Jaguar 1200 set the world record in Dalhart, Texas in 2025, processing 4,096 tons in 12 hours and filling 266 truckloads at a rate of 1 every 2 minutes and 42 seconds. The engine is a MAN V12 24-liter unit, producing 1,110 horsepower, equivalent to 6 large tractors working simultaneously. A 910mm chopping cylinder cuts the entire plant into uniform 17mm pieces. An onboard near-infrared sensor measures moisture, crude protein, and starch content in real time and adjusts chop length based on what it reads. The machine does not separate grain from plant. It processes everything into homogeneous silage. A multi-crop cracker system uses 2 rollers to pulverize every grain kernel in the chopped biomass, increasing the energy available to the cattle that will consume it. The resulting material is blown through an accelerator spout at high velocity into a trailing truck. A logistics chain of 30 or more articulated lorries is required to keep one unit running without interruption. Dairy cattle require silage fermented at precise moisture levels to sustain high milk yields, and the forage harvester is the only machine capable of clearing enough acreage within the narrow nutritional window that makes that possible. The grape harvester. The grape harvester is the machine that turned wine from a handcrafted regional product into a global industrial commodity, and it operates by straddling the vine rather than picking from it. The machine drives directly over the trellis row, and inside its frame, rubber or fiberglass rods vibrate the canopy at frequencies calibrated to match the detachment force of the specific variety being harvested. Ripe grapes fall from their stems, while the stems stay attached to the vine. High-velocity air blowers remove leaves and debris before the fruit drops into collection bins. One machine covers a hectare in under 5 hours. A human team takes between 1 and 10 days on the same area. Modern units run continuously through the night, and winemakers now schedule 3 a.m. harvests because lower temperatures preserve volatile aromatic compounds in white grapes and reduce oxidation before the fruit reaches the tank. Research on Sauvignon Blanc shows measurably higher aroma compound levels in machine-harvested fruit gathered at night compared to daytime hand-picking. In 2021, COVID travel restrictions eliminated the backpacker workforce that normally picks the Hunter Valley vintage in Australia. Mechanical harvesters gathered the entire crop. Without them, the full vintage would have rotted on the vine. The orchard tree shaker. The orchard tree shaker is the primary harvesting tool of the global olive oil and nut industries, and it works by applying a controlled seismic event to one tree at a time. A hydraulic arm extends from the machine and clamps onto the trunk using padded jaws. Eccentric rotating weights inside the clamp head induce vibrations at between 15 and 25 Hz, a frequency matched to the resonant characteristics of the specific crop being harvested. Radial stress on the trunk reaches between 3.5 and 6.9 megapascals, enough to dislodge fruit anchored 6 meters above the ground. A self-deploying canvas surrounds the base of the tree and catches the falling fruit before it contacts the soil, preventing bruising and bacterial contamination. One machine processes 50 to 60 trees per hour at a fruit removal rate of 95 to 99%. If the shaker pads are not properly lubricated, radial stress reaches the upper limit of that range and can permanently restrict the tree's sap flow, reducing long-term yield. Spain produces roughly half the world's olive oil, and the harvest is mechanized almost entirely by trunk shakers, operating across super-intensive groves, planted at densities exceeding 300 trees per hectare. Without this machine, olive oil and commercially priced nuts would not exist at the volumes the global market currently depends on. The peanut digger inverter. The peanut digger inverter is the only harvesting machine whose primary function is not collection but repositioning, and the reason for that is biological. Peanuts must dry in the field for 2 to 3 days after being dug, before the combine can thresh them. If they dry pod side down, moisture from the soil promotes aflatoxin mold growth that can render the entire crop toxic and unsaleable. A horizontal blade cuts through the soil 7 to 10 centimeters below the surface and undercuts the root zone. The plant is lifted onto a vibrating rattler bar conveyor that shakes soil from the roots and pods, then fed through a series of inversion drums that rotate the entire plant 180 degrees and lay it back on the ground with the pods facing upward toward the sun and open air. Precision machines achieve an inversion rate above 89% and a buried pod loss rate below 0.31%. Manual peanut harvesting requires 84 labor hours per hectare. The digger inverter completes the same area in under 1 hour. In Georgia, India, and China, where peanuts are a primary protein and oil crop, inversion is not optional. It is the mechanical boundary between a viable harvest and a field of contaminated food.